So now it's time to start a discussion about getters and setters, because so far in our videos, even though we didn't see explicitly the getters and setters here, we've used the getters and setters every time we got the value of a property and every time we assign a new value to a property. And the getters and setter in Kotlin are implicit, so they are declared, they are auto-generated by default by Kotlin for you. So every time let's say you get the value of an object, let's say that you get the value of the user, that first name, what actually happens here is not that we're getting the value of the first name directly, even though if you look at the code, this is what it seems to be. What is happening is that every time we get the value of a property, that value is returned by the getter. So you never access the property directly, and you never thus change the property of the value of a property directly. Every time you are using the getters and setters. And now this discussion is touching on a very important concept in Kotlin programming, and that is encapsulation. So encapsulation basically means to protect, to hide the inner workings of the class from being accessed outside. And if you look at this syntax that we have here, it seems that we actually accessing the values, the properties directly. But as I said, that is not the case, because we always using the getter and the setter. And because we always use the getters and the setters, the getter to get the value and the set to change the value of a property, that means that your data, your properties are never accessed directly. Thus, the laws of encapsulation are not broken. In other words, you never allow somebody outside of the class to access directly that property. So this is why we have getters and setters, and this is why the getters and setters in Kotlin are implicit. So they are not even declared explicitly here. We don't see any code which will imply that we have a getter, a setter here, because they are automatically and by default generated every time you define a property. So every time you define a property, either in the primary constructor or inside the class, the getters and the getter and setter is automatically generated for you. But let's say that you want to override the getter and setter to provide some additional code to the code that is by default provided. You can do that by changing, let's say, this property to a parameter, and to override the getter in setter and to see how the getters and setters actually look under the covers. Just type here var. We define the property, first name. We assign the first name parameter to property. Now, the getters and setter need to be overridden immediately after we define the property. So we cannot have some code here and then to override the getter and setter. So we need to define them immediately after we define the property. So we type here get, and as I'm typing, you see that I have some suggestions. Then you go down here and you can choose this one. So you have parentheses, curly braces, and inside the curly braces you press enter. Here you type return field. I'm gonna explain immediately what is this. And now we need to override the setter. And to do that, we just type set, and I have some suggestions. We also go down here, we choose this one, press enter, and here we type field again, this identifier, and we put equals to value. So this is the implicit code that is generated, that is auto-generated by Kotlin for you every time you define a property in your class, either in the, as I said, in the primary constructor or inside the class. So because in fact, if you look here, we have some underlines, and if you hover over here, it says redundant getter, remove redundant getter, because and also for the setter, redundant setter, because they are redundant because they are implicitly, again, auto-generated by Kotlin for you. So this code is redundant here. You don't need this code because Kotlin already provides this code under the covers for you. But if you're not satisfied with this code, with this implicit code that is auto-generated by Kotlin, you can override them like we did here and provide some additional code. So we can put here, let's say, some text, so that every time we get the value of our first name property, we're gonna have a prefix. And let's put here first name. Let's put a colon, $, and field. I'm gonna explain immediately what this field is, but let's say first how this works. And here let's put a println to print the value that is passed to the setter and then assigned to the first name property. So let's put here $, value was assigned to first. So now if you run this code, now we have name, so we have our text that we have here, name, and then we have first name Alex. Let's actually delete this text to make things more clear. Let's delete this text. Let's delete this. Now let's run this code again. So what we have now is that every time we get the value of our property name, we have that prefix first name that we have overwritten here in the getter. So the getter is called, as I said, the value is returned by the getter. So the getter is called, it returns the value of the first name property. So this field is the first name property, but it has this identifier field because of an important reason, which I'm gonna explain immediately. So it returns the value of the first name property with the prefix first name, and we have first name, the text that we have here. Then we have the value of the first name property. We have Alex in our case because our object has the name Alex, has the property name Alex. Then for the setter, we don't have any code here. Also, we have the first name prefix for John. So our code, every time we get the first name property by any of our objects created by using the user class, it gets that value, it returns that value through the getter. And the setter, we don't have value as assigned to first name property because the setter is called only when we change the value of a properties. And to do that, we type user, like we did in our first video about object-oriented programming, dot first name equals, let's say, let's put here Vlad. So now if I run this code, now the setter is going to be called because the setter is called, as I said, only when we change the value of our property. So we get Vlad was assigned to first name property. So the code inside the setter was called because this code that we type here is calling the setter. So our code always goes to the setter. And the code that we have here, user.firstname Vlad, what it's actually doing is passing that value Vlad to here. So this parameter that we have here is receiving the value of Vlad, and then that value is assigned to first name property. Again, we have this field identifier for a reason, and the reason is going to be explained immediately. So the getters and setters are working well, and they are, as I said again, the use always when we get or we assign a new value to our properties. Now, what is this field identifier? Why I didn't type here first name, and here I didn't put first name? equals to value. So whatever value is passed to the setter, then that value is assigned to the first name property. So why we don't do that? And the reason for that is that because this syntax user.firstname equals Vlad is calling the setter. If we put here first name equals value, so first name equals Alex, it will be equivalent to call the setter again. So this line of code that we have here, it will call the setter again, it will pass the value to the setter, and then it will assign the value again to the first name. So it will call the setter inside the setter forever. It will generate an error. And to avoid that recursive call, that infinite call, we need to use this field identifier. So the field identifier is the first name property, but it has this special use that it bypasses that error that it will be generated if you use the first name here. So in fact, let's put here first name to see. So if you put here first name instead of field, and we have an error here, let's put here field, because I want the error from the setter to get in the console, not the error from this thing here. So now if you run this code, as I said, that will generate a recursive call. It will call the getter over and over. So get the error. So you see we have Vlad was assigned to first name property, Vlad was assigned to first name property, Vlad, and so on. That is because the setter, it's calling the setter forever. It's a recursive call, because this line of code here, it's calling the setter, it's assigning the value to the, sending the value to the setter, then that value is assigned again to the first name property, which in turn calls again the setter, and so on. So this field identifier is used because it has this characteristic of bypassing that error. This is why we're using the field instead of the first name property here. And it's basically the first name property, but it has this specific characteristics which bypasses the recursive call which we got when we've used the first name property. Now if you run the code, now we have no error because the recursive call is not happening, because we're using the field which bypasses that error. So this is why we're using and Kotlin has this thing field, and the field can only be used inside the getter or the setter, not anywhere else outside the getter or the setter. And the same is true about the getter. This is why you need to use the field identifier inside the getter also, because it will generate a recursive call again. Now, to illustrate better, because you maybe find confusing this discussion about getters and setters, what they really are. They are equivalent to having two functions which update the first name property and return the first name property. So they are equivalent to having a function called set first name, and this function defines a parameter called, let's call it new value. It's gonna be of type string. Let's put curly braces, and here we type this dot first name equals new value. And the getter is equivalent to having a function called get first name, and this is not going to take any parameter. We're going to say explicitly here that it's going to return a string, because it's going to only return a value, and this is going to return the first name property. So we put here this dot first name. So the getter and setter that we have here are similar. This is illustrative for you to have in mind, to having two functions which are setting the first name property, are updating the first name property, and are returning, let's change this to first, and are returning the first, the value of the first name property. But because Kotlin is about conciseness, it has this special syntax, and they are automatically generated for you, because as I said, Kotlin is about conciseness, so you don't need to declare those things every time you create a class. So let's delete this. So have in mind that under the covers we have something like this. So let's delete this. Now the error disappears. Also, you can have a shorter way of writing the setter and getter if you don't provide some additional code. So if I delete this and this, I can put here get equals field, and yes, this is okay, because this is like having a single line, a single function, a single line expression function, because we're returning the value to the function get. So you can write it like this, or I show you this for you because maybe you'll see written in this way and you may be wondering why. That is because this is like having a single body expression function. So you can write it like this if you want. But again, if you hover over, this is still redundant. Let's press Ctrl Z to have the previous code. So this is our discussion about getters and setters, and see you in the next video.